The value of coefficient of volume expansion of a glycerin is 5 into 10 to the power of minus 4 per Kelvin. The fractional change in the density of a glycerin for a rise of 40 degree centigrade in its temperature is. Given the value of the coefficient of volume expansion is, that is 5 into 10 to the power of minus 4 per Kelvin, then the original density of the glycerin is written as, that is rho is equal to rho naught times 1 plus y into delta t. Then if I'm going to simplify this one as rho is equal to rho naught into 1 is rho naught into rho naught into y into delta t, then rho minus rho naught is equal to rho naught into y into delta t. Thus, the fractional change in the density of glycerin for a rise of 40 degrees centigrade in its temperature, then that we can write it as rho minus rho naught divided by rho naught is equal to y into delta t, which is nothing but 5 into 10 to the power of minus 4 is y, and delta t is 40 degrees centigrade. Then by simplifying 5 into 4 is equal to 200 into 10 to the power of minus 4, we get the value 0.020. Hence, by seeing this answer, we can say option C is the right answer.